Yo, what's up, guys? This video we're going over the power rule for derivatives. This is a big step for your calculus career on your course to being an engineer or whatever you want to do. Quite frankly, I don't really care what you want to do, but I'm going to teach you regardless. So, first thing we got to know about the power rule is this little rule here that I'm writing down. So if f of x is equal to x of x to the n power, all you got to remember is that f prime of x, that's what this little 1 here does, is equal to n times x n minus 1. That's it. That's the entire derivative. Now, there's going to be little things we're going to have to get to later where we might have to use some algebra to do these derivatives, but it's pretty much that simple. So let's try some examples. If we have an x to the 5th power, or let me rewrite that. We have d over dx, x to the 5th power. This d over dx pretty much just means take a derivative of whatever's inside of those brackets right here. So with this thing, if we follow our little rule that's written down right here, we're going to take the n, which is the 5, and put it out in the front, multiply it by the x, and then we're going to do the 5 minus the 1, and that is equal to 5x to the 4th. Yes, it is that simple. So what if we have, for our second example, just a solid x? You might be like, what do I do? There's no n. Well, there is an n. The n is just hidden. X to the 1 is the same thing as x to the nothing. Well, it's not the same thing as x to the nothing, but it appears as nothing if there's a 1 there. So what do we do here? Do it with me. We bring the 1 down, multiply it to the x, 1 minus 1. X to the 0 is just 1, so we're left with 1 times 1, which is equal to 1. That's our derivative. This was still a d to d over x, by the way, with that in bracket. Next example, example 3. 4. We just have a 4. What do we do here? Well, x to the 0, as we said, is 1. First of all, let me just say, if it's ever a constant number, a 4, 5, 13,000, 15 billion, the derivative of that is always going to be 0. But to prove why, we're going to go through this example. So 4 on its own is the exact same thing. Let me write that d to d over x. I'm always forgetting that. A 4 on its own is just 4 times x to the 0. Because x to the 0, as we went over before, is just 1. So therefore, if we follow that same logic as we were doing previously, we bring the 0 to the front times the 4, 0 minus 1, and because the 0 times the 4 is 0, whatever this is doesn't really matter. So we're left with 0. Now let's make it a little bit more complicated. But this is as complicated as it's really going to get for the power rule. Fourth example. Let's say we have the square root of x. This one's a little bit more complicated. But if we use our algebra skills that we learned in college algebra or just on Google, maybe from my channel, we know that the square root of x could be rewritten as x to the 1/2. So now, let's do that same logic that we were doing before. We bring the 1/2 to the front, multiply it by the x, and then we do 1/2 minus 1. And what are we left with? We're left with 1/2 x to the negative 1/2, which is the same thing as if we rewrite it again, 1 over 2 square root of x. That's a complicated thing, not very pretty to look at, but pretty simple to follow, and with practice, you guys will be doing that in your head. Or girls. So, for my last example in this video, let's say we have a 1 over x cubed. Let's make it crazy. Let's do an x cubed. How do we solve this? You may be wanting to do the derivative on the bottom, but that's entirely wrong. Do not do that. What you do is just like the square root problem, we rewrite it. So what is 1 over x to the cubed? In a way where we could easily use our formula that we were showing before. Well, 1 over x to the cubed could be rewritten as x to the negative 3. Because whenever you bring anything from the denominator up to the numerator, it just makes a negative. Well, any exponent is what I mean. So let's take the derivative of this. And by the way, all these examples I'm giving, I encourage you to pause, try them on your own before I even show you. And then after this video, I advise you to do a million more problems. There's plenty of derivative videos online. I'll have more coming out. You'll be able to get a lot of practice in this thing. So anyway, let's without getting sidetracked, let's get into it. So x d to the dx, x to the negative 3. What do I do? It should be like that, by the way. What do I do? Well, we bring the negative 3 down, multiply it to the x, and then lastly do the negative 3 minus 1, and we are left with negative 3 x to the negative 4, which again could be rewritten as negative 3 over x to the 4. That's our answer. It's all very, very simple with practice. It may not come easy for you. That's totally normal. But like I said, with practice, you'll be doing it in your head. To get off, or to end this, I'm going to give you a few problems. Like I said, you should practice. Please do these. Do not think you watch this video and you understand it, because that is not how math works. You got to keep putting the effort in. Got to keep practicing. I learned that the hard way. So, yeah, let me give you some examples. First example. Second example. Third example. That should be a 3. Fourth example. And that's where I'm going to leave it. Thank you all for watching the video. Please complete these problems. I will put the answer in the description of the video. Please like if you enjoyed, and good luck with all your tests or just whatever you want to use this knowledge for. I'll be making more calculus videos. Thank you all very much for watching, and I'll see you later.